Hello everyone, my name is Syed Mustaqim. I am from TY BTech Electrical Engineering from Sanjuni College of Engineering, Kopargaon. We have the topic of wingtip simulation, and my group members are Pratik Kadu, Sanket Kadu, and Shubham Sagar. Let's start the simulation in MATLAB. For the simulation, we need some calculations like output power of turbine PM. Formula for the PM is 1 half into Cp into gamma into beta into rho into A into VW. Then we assign the value for the output power of turbine is 5000, 1 half into Cp into 1.225 into pi into r square into 12 cube. Then we get the value for r square, and r is the 1.91431. Then PM is nothing but the mechanical power output. Then rho is the air density, and it's 1.225 kilogram per meter square. Then Cp or C rho gamma comma beta equals to performance coefficient of wind turbine. A is nothing but the air swept in meter square. Then VW is a wind speed in meter per second. Then gamma is equals to tip speed ratio. Then beta is the blood pitch angle in degree. We need all the values for the remaining simulations. Then Cp gamma comma beta equals to C1 into C2 upon gamma I minus C3 into beta minus C4 into beta x minus C5 E into E upon 1 minus 6 upon rho gamma I. Then we get the value for the performance coefficient of wind turbine, and that is the 0.41034. Then C1 to C6 are the constant. Then 1 by gamma I equals to 1 by gamma plus 0.08 beta minus 0.035 upon 1 plus beta cube. Then gamma I, we get the value for the gamma I, and that is nothing but the 11.304. Then gamma equals to just gamma. Here is gamma I, and there is gamma, and the value for the gamma is WR W suffix R into R upon VW, and we got the value for the W suffix R, and that is the 50.775. Then for the 5 kilowatt of wind turbine, we get the values. Gamma is 8.1, then Cp that is 0.41034, then VW, that is the air density is 12 meter per second. Then beta, we got the value for beta is 0. Then R 1.91431, and then C comma means C. For the C1 the value is 0.5, C2 the value is 116, C3 the value is 0.4, C4 that is the value is 5, and C6 the value is 21. Then gamma I is 11.304, and WR with the name of wingtip simulation 47. It's my roll number, and we first save the simulation, and let's save. It's taking too time. Okay. Then we search for the subsystem. We search for the subsystem is coming, and we divided the subsystem in two parts. First is the input, and another is the output output of the system. Then we take the product. Let's take the product. It's coming. That is the product, and we give the 4 inputs for the product and 1 output, and straight down for the product. Then we search for the constant. Constant is coming out. Wait for a second. Then it's come, and constant, actually it's not the constant, it is the gain. Then we search for the gain, and gain is coming, that is the gain, and we give the value for gain is 1/2. Okay, then we connect gain with the output and gain with the product. Then we copy the gain. We give the name for the inputs of the product, that is A. For another product, it's take too much time. We search for the gain, and the value for the input of the another line is v cube. Then for the another input number 3 is air density. Air density. Then we search for the we give the name for the 4th input of the product, and that is what is the CP. And then I connect the gain with the first A. It's air density. Then I search for function block. Wait, this is not that function block. I search for that. Wait, then I search for the function block, and it's coming out function block, and function block is connected to the gain, and we give the value for the function block is u1 square. Wait, it's taking too much time. u1 square. Okay, then we are adjusting the input function block, and
we have to take now one SP, then we have to give new u name as VM in bracket m into seconds. Then because we have to take measurement in second, then we have to take one function module to connect to v raised to 3. Then we have to connect it to VM seconds. Then we have to take one constant block for the constant flow of supply. And then the measurement of the constant block is 1.225 in IMFT. Then we have to connect it for air density, which how much pressure the air should be there. we should connect it. For the further module, we have to take one subsystem for the CP. CP is nothing but the pressure. We have to take now CP subsystem, not CP. In that CP, we have to delete the flow of current or the flow of path. In subsystem, we have to take one function module, block system, and constant flow of supply. Now we have to give the name CP and int 1 for these two parameters. Then we have to take one function module, one function module. In that function module, we have to assign the value of it as sine in bracket t into expression 2.13 into minus 0.2. The further will be explained by Shubhan sir.
Double click on function module and write the expression 0.5 bracket 116 into 116 into u, then bracket into 1, then minus 0.4 into u, bracket is the right up to the minus minus 5, then minus 5 to a function module. This is expression the minus 5 bracket is completed, then outside the bracket into exp is the expression, then bracket minus 21 into u, and multiplication bracket is in 1. These are the expression of function. Then click on OK. Then add to the function in a CP. There, and one more add a function in MUX to output function is 1. MUX output function is 1. Then add the function Then the input function is 2, input 1 and input 2. Their name as to the lambda, and second input function is beta. Second is a beta. Then one more add to MUX. Then MUX is input function to lambda and beta to attach the two input function in MUX. Then double click on lambda. Its port number is 1. Then the MUX is U2, downside is a U2 and upper side is a U1. Upper side is a U1. Then one more function is add.
Myself Shubham Sagar, and I am from the TY Electrical, and we done the MATLAB simulations for the wind turbine power generation. This is the second equation which gives the CP or a power, and here we use the multiplexer for the number of inputs and single output. So in this video we can see that we give the input and the output is coming. So the number of inputs is connected to the multiplexer. From here we use the two saturations for the signal output and the one display for the show the output of the system, output of the transfer function. So for this we simply search on the library functions saturations and get the two saturations for the signal or the output, and this is connected according to the block diagram. Here we give the display which are connected to the third and the fourth multiplexer, so it will give the output or show the output. So next is we can connect all the blocks and the saturation and display according to the block diagram or the functions, and we can give the output using this.
There are 4 constants. First is add a RM, second is VW, third is beta, and fourth is then double click on constant 4, then constant value is 50.775, then add the W, then add a one display to attach a PM, then copy the one display and then add a TM, add the TM, then display 1 and display 2, then name the display 1. Display 1 is a power, and display, and then name the display 2. Display 2 name is a torque. Display 2 is a torque. Display 2 is a torque. then add a power guy to the continuous function. Power guy is a continuous function. Then run the system. This is the output of the system. Then click on the function. Is a expression of the function is 0.5 bracket 116 into u more bracket 1 minus 0.4 into u 2 bracket 2 bracket minus 5 bracket completed into exp means expression bracket minus 21 into u in 1 into 1 bracket completed. It is expression of function. Then make expression, and this is a system, this system subsystem, and then run. The value of power and torque is display. The fourth subsystem is completed.
Now we are going to run the simulation. After checking the error and correcting the error, and we find that the subsystem there is no error now. Then you can see the system. In system there is a 4 display. You already seen that. Then you can see that all the components, all the blocks, and there is the simulation, and we run simple, and we got the display values of power. You can see that there is a 4 display, and you can see simply the value for all the displays. What is that? For the torque is 115, for the power is 5002. Then here is subsystem, there is no error. You can see all the function blocks, all the displays, all the sine wave components. Here is the 5 kilowatt turbine system, and you can see that all the values and displays. There is no error. There is no any chance, and we are simply adjusting all the blocks of constant because it's looking good. We are adjusting the blocks. Now you can see that there is extending the block. Okay, and now it's looking good. It's looking better than old. That is our project. That is the values. You can see 5 kilowatt turbine system. That is the system. Then you can see in the subsystems there is no error. Okay, thank you for watching our videos.